Okay, hello class, weekly update 9. So you finished module 4, week 2, and a couple comments on samples and examples. So I'm going to share the screen and go into Zoom here. Oh, I'm sorry. From Zoom, go into our OAKS. And so you should be seeing how OAKS looks on my side, but I put in module 4, samples and examples. So we had a bunch from week 1. So go ahead and take a look. I particularly want folks to look at the optimization. Chloe and I both noticed that seemed to be a weak spot for folks. So there were some really good ones. Rian's, Sam's, and Jenna's optimization very clearly laid out what to do. I can promise you there will be at least one, maybe 2 optimization problems on the final exam. So take a look at that. And then in week 2, just this past week of the homework that you guys turned in with the due date last Wednesday night, so last night, there were some assignments I really like. So here's Lily's. Let's see, these are activities, and then Ellie's activities, nicely marked what her thought process was, and Grace's. Oh, and yeah, Grace's was really nicely delineated on the activities, and then also the activities by Sam. Some folks struggled on the area integrals and dy dx, dx dy, flipping those. And I think Sam had some really nice pictures, and that would help folks. So if you had trouble on a couple of those activities, helping visualize, take a look at Sam's. And then Jenna made a really nice video as usual with her thought process for her activities. And Jenna's calculations on those were also very well laid out. So please take a look at your classmates and go over those. Again, this is your way to start. It's time now. We're like 2/3 the way through the semester to start preparing for that, thinking about that final exam. And some folks in the discussion board for module 4, I hope y'all are getting together and making a plan to study. I think that was Grace and Jenna and Nia, some folks that I remember. So please take advantage of that to have study buddies. Okay, next thing, this is also thinking about advising. So some of you, we already got several math majors in class and some math minors, and many of you should consider that given your majors. You guys are rocking the class. It's just awesome. Really, really excited for you guys. And so some of you should consider picking up at least a math minor for like your physics and astrophysics and chemistry majors. It's so easy to do that. I think it's like 1 or 2 more classes. You already take so many math classes. So if you need any advice on that, I can point you to the folks. Kate Owens is our associate chair of mathematics, and she can give you great advice. But speaking of Kate also, she teaches our Math 203 next semester. So let's see, what are we in now? So in the spring, yes, we're in the fall now, yes. So in this coming spring, Kate will be teaching Math 203, which is linear algebra, which many of you need for your majors. And so there's 2 sections of that, and I just want to tell you, please take Kate's. You'll have a way better experience and a much better time. So if you can quickly get into the Math 203 with Kate Owens. Okay, the next thing, you guys had the big assignments this week were your challenge problems, and there's some really cool ones. So it was neat to see how many different ones were done. So this time there were some groups that did number 7, some groups number 8, some number 9, and some number 10. So all of them were covered. And some of my favorites, so I'll just talk for challenge number 7, that was the one where you had a couple topo maps in the corners and you needed to see if there was enough land to be cleared and pushed over here to make like an amphitheater or something. And Grace, Cam, and Jonathan, really nice job with that one and all the level ups that you did. Lane, Sam, and Jenna also chose that one. They had excellent images and figures in theirs. It was so clear to see using both tech tools. I think a couple by hand, how they improved their approximations, and they showed those like midpoints that they did each time. And then group 13 is Christian, Colin, Charles, and Zach. As usual, just concise, succinct, to the point. Also nice images and figures, but always like very efficient in their writing. Challenge number 8, several groups did this one. This was the one with the auditorium, and I think everybody that chose this one emailed me that there was an error that I had the 2 surfaces flip-flopped. So like what I said was the ceiling actually was below. So y'all figured that out. You need to flip-flop those 2 surfaces. And so you had a ceiling and a floor in this auditorium, and you had some questions about both volumes and surface areas. And then some groups did level up. So Joe, Filippo, and Brianna with an E, excellent images, excellent modeling of that one. There's very clear explanation and how they chose to set up the models. Lainey, Brianna with an I, and Lee. This was, in my favorite in this one was Brianna's color coding of her explanation and her work by hand that she checked with a tech tool. So maybe I'll share this one. So that was group 9. So let's go to, that's 105. This is y'all 221, group 9. Again, Lainey, Brianna, and Lee is this team. And these are the, oh yeah, you guys are the John Tates in the making. I like that team name. And then for challenge number 4, yeah, here's your final report. Nice images of the floor and ceiling, and even better uses of the tech tool. I think for this one, Joe, Filippo, and Brianna, their images were just, they rotated them certain ways and really became experts at using CalcPlot 3D. But again, one section of this that I really liked, I think this was Brianna's handwriting here. She computed these volumes, did it all by hand, and then made sure she checked it. But I just liked that she was solving for this parameter and this level up, and she was like, okay, A is the thing I want to find. And she's really focusing on that, put it in red, and then solves for it at the end. Same thing when she gets the volume later, and always uses a tech tool to check her work. But it's like ones that she can do by hand, she does by hand, and this is an important skill for your final exam because you have to show your work, and this actually goes to a curriculum committee is checking things. So you have to be able to do these basic ones by hand, but then there were some parts of this, like when you get to level 4, I think Leah was doing this one by level 4, you know, you can't, you're gonna have this messy square root in there. Even if you're looking at tables and like really simplifying, you're still using a table to help you do this. You can't do those by hand. And so there will be some of those on the final, but the ones that are basic, where they're really just kind of polynomials, like the one Brianna's looking at here, yeah, you should, that should be one you can do by hand. So no problem, and you have to show your work for the final. Okay, next, also on this auditorium one was the team of Jeff, Nate, and Haley. I just really like seeing your report every time because it really appears from my side that you have great teamwork, and it seems like you have fun doing it. It's very shared each time who's doing which parts, and understanding and checking each other. Excellent images. And then group 1, this I think is the STEM Brothers team. As usual, just succinct and clear, to the point of it. It's like everything is there, and it's easy to grade, easy to read. Okay, then challenge number 9, several groups did this one. Challenge number 9 was the one where you had this tent, that tent that we've been doing the whole time through that section, that chapter. Sine x times cosine y, I think it was. And so group 2 was Lily, Ethan, and Dallas. They did this one. Nice job, very nice visuals. And then group 3 I really appreciated was Jennifer, Brooke, and Caroline. Did several level ups and really good work, and challenged themselves and extended it. But I think the one I want to show, and one of my favorites from this one, is team 9. So, no, sorry, team 11. Team 11 is Shreyas, Emma, Ellie, and Nia. And they chose to do the tent volume, and I really liked the pictures in this one and the thought process. So let's get down to their final report. Okay, so there's our surface. That tent is in the blue, and then this was the dividing line to make 2 sides for 2 roommates. So you have a roommate sitting over here and a roommate over here, and they're like, oh, visually it's clear that like this guy's got the bigger one, but how much bigger? And actually I think this was Jennifer, Brooke, and Caroline really broke that down to like it's almost twice as big, I think, is what they did when they did the volume computation. But what I liked about group 11, Shreyas, Emma, Ellie, and Nia, was they had several different ways of thinking about this. So they just really started off by visualizing with the 3D graph, as most people did. And then they did this method too. They were like, well, let's think about this in terms of the contour plots. And can we, there's your dividing line. One roommate's over here on this side, one roommate's over here. And they said from the contour plot, again, we still, that's confirms our suspicion, but we can be a little more precise. And then they went to using calculus, to test our suspicions. Like we'll actually get these volumes and dividing it in half and seeing how different they were, 0.7 and like 0.3. yeah, about 2.4 times larger. Same thing that Jennifer Burke and Caroline got to that. And then the thing was, well, where should you slide this dividing partitioning wall? And they show some nice figures here, again, for the different places that they moved that vertical plane. And again, some nice images. What if you guys are having trouble getting your images to sit vertical, that Z-axis, that can be a little bit tough if you're using your mouse pad, but use Lane's tip that you can just use your arrow keys and it'll give you much better control to actually get that thing vertical, sit upright. And then they also show their by hand work, again, ones that can be done. This was great because they explained, okay, they use Frobenius theorem, split this into easier ones. Yeah, and then they go into their level ups. So they did several level ups. This team really rocked it on this problem. I think in this one, you were, oh yeah, now instead of vertical, it's still vertical, but it's angled. I think it had to go through the origin and figuring out what's the way to divide that perfectly. Yeah, here's another extension of it to level 3 and talking about surface area this time. So excellent job overall on that team's work. And then the last one, the only team, kudos for trying this one, because I do think this one is a little bit of a doozy. The fuel tank problem. So this was group 12. This is Eddie, Michael, Cameron, and Kyra. And the fuel tank problem had some subtleties. I mean, it maybe at first when you read it, you might have thought this is doable. Once you got into it, you realized it was a little trickier. So you had this sort of pill-shaped fuel tank, and maybe it would be upright or one-sided. I don't know that it's specified, so I think they thought of it as upright. And you're trying to figure out in this problem, where do you put the 10% full tick mark, the 20%, 30%, and had it been a cylinder, no problem, right? So it's just equally spaced along that vertical axis. But because it's got these unusual shapes on the bottom, which still are geometric, it makes the problem a bit more difficult. And so they're working through their integrals here. They show testing things with this table of where it could be to actually fill out that volume. And then they're having to check that with their integration. And I think this was Kyra who used Desmos to sort of put together, rather than using Calcplot 3D, these two ends of the pill, I guess. Yeah, a little more. Okay, and then stop the share there. Okay, so then the last thing is, whoa, congratulations, you finished Journal 3. That's a lot of material. And you're about to start in Module 5, Journal 3.5, which I think is super cool. I think it's even more interesting extensions. We're going to be looking at space curves that move all through R3. We can have so many more interesting functions we can describe that way. So we're doing vector calculus now and vector functions. And then we're going to talk about parametric surfaces and get surface areas of those crazy shapes, but we'll take derivatives in different ways. So a whole new way of thinking about and extending some of the ideas you had in book 3 to book 3.5. So I think you're going to find it very exciting, very visual, many more interesting applications and challenge problems. And oh, but I should say that thank you guys for being so patient with book 3 and finding all these errors. And hopefully they weren't too many that were just like really impeded the learning or throwing you off. Like for instance, that what was it, challenge 8, where I flip-flopped the floors and the ceiling of that auditorium, but you guys figured that out. And again, hopefully that didn't frustrate you too much. So, but you found several errors, and I appreciate that, and thank you for being patient with me for not having these perfected at this point. You guys are kind of guinea pigs. But all that is to preface that I think you're going to need even more patience with me for book 3.5, because I already found just in shooting some videos for this one some errors, and I have to insert a couple pages, so you'll see that in some of your assignments that it'll say like go to page 177C. Well, there's a 177 in there, but there's not a 177C. So I inserted that into Oaks and made a PDF file. I've already done some corrections, but I'm excited about book 3.5. I'm really proud. In fact, once I found out in like June that I was teaching this class, I just sat my butt right here in this chair all summer with a fan right next to my face in 90-degree weather, sitting out here trying to get that done. I worked like 14-hour days, 7 days a week for 6 weeks and created that thing. And that's not to say like, oh, poor you, Amy, thanks for doing that. It's really to say, I apologize. I know there's going to be errors, and I just hope there aren't too many that are going to impede your learning, but let me know and I'll get that out to the class and make the changes as we go. So continue to be patient, but have fun and enjoy them. I really think you're doing a fantastic job this semester. And I'm excited to see where we're getting closer to that finish line and how we're all just gonna like run through that and ace it. All right, well, have fun with module 5.